Dan, like we said a little bit earlier, you've been doing some malware analysis, found a new little twist. What can you tell us?
Yes, we did. Actually, one of the multitude of samples that comes across our desk, one of the techniques we use is to do some dynamic analysis to extract interesting indicators and help us to classify the malware. So in this one case, we found a piece that wasn't running quite right through that whole architecture, and so that required a little bit more digging into. So we went ahead, we reverse engineered it, and we found an interesting twist. What it did to disable the ability to do the dynamic analysis is it reset all the network connections. So it disabled all the network cards, waited a few seconds, and then re-enabled them before proceeding to the malicious logic. And that pretty much took away the ability to do dynamic analysis. Now, that didn't stop us, obviously. We're still able to analyze the malware and do things with it, but it is an interesting twist that I think probably more threat actors will probably adopt.
Right. So this is a case where if you weren't really paying attention to what's going on, just kind of running the things through, the thing would just fail, and you don't really notice that, if you had a lot of volume going through, that might happen. But since you're paying attention, we're able to pick up on this.
Yes.
And it's so in the dynamic analysis, basically what you're trying to do is use the computer, observe its behavior while it's running. Is that?
That's basically it, right? There's usually a collection script that tries to pick up the information as the sample is running, and by resetting the network card, that seems to break. So it's something to keep an eye on as a technique. I know that anti-VM tricks are used a lot, but this one seemed to be actually quite effective and quite simple.
Yeah. So you don't suppose that the malware writers here happen to have their own dynamic analysis and are perhaps checking the same kinds of things?
Well, I suppose that's what they're doing.
Right. Well, I mean, we've known for some time that they test against antivirus to make sure that they are not getting triggered by signatures, and this will be a case where they're realizing that there's, static and dynamic analysis being done as well, and trying to evade those.
Yeah. What was interesting about that sample is actually if you just use static analysis without any dynamic, without trying to run the sample, if you just looked at the strings output, actually, you got a lot of interesting information, the kind of information we'll look for in order to classify the sample. But if you try to run it, that's where the failure came in. And obviously, like you said, we always want to look at those exception cases to make sure we're always ahead or close to the curve.
Yeah. Now, this particular malware, this wasn't just your regular run-of-the-mill malware. This was a case where it's generally used to target specific organizations. Is that right?
Yeah. This is something that most people would consider an advanced persistent threat and came from a threat actor.
Okay. So it's obviously something we're going to be needing to pay a little more attention to as we go here. I don't know. Any comments from you, Dave?
No, just that it's interesting that such a simple technique messes up the complex analysis that we have, but that seems to be always the case, right?
Well, it didn't mess it up.
Right. Slow this down, let's put it that way.
Yeah. Right.
But, even commercially available systems that do this kind of malware analysis broke down as a part of this process. I think probably because, they're starting up and they're trying to do some packet capture, and they've got, a hook into the network interface, and then when the malware drops that process that was trying to collect packets also, stops because of that. And doesn't know enough to restart itself. So it's an interesting technique, and I would advise to other people out there that do malware analysis, if you get samples that look like they're doing things statically, like from your static analysis, it seems like there should be something happening here network-wise, but they don't do anything, you might want to take a closer inspection like Stan did to realize that there's more going on under the covers of this code than you expect.
What it did was it broke the dynamic analysis environments that that have hooks into a VM or into a machine that gets infected. One of our analysis environments that is completely passive wasn't affected by this at all.
Right. Yep. So I guess that's another sort of rationale behind passive analysis. I guess I've been always an advocate of passive analysis because it's one of those things that's very difficult for an adversary to even know that it's there or how it achieves its purpose. Anytime you can get to that kind of scenario, it certainly helps to provide the ability to throw an extra little twist in there. They don't really know how you detected things and how to how to evade it.
It's also a good reason for having multiple ways of analyzing your malware and not just depend on on one tool to do your analysis.
Yep, very good.